Comparing the boiling points of a homologous series of straight-chain alcohols with their equivalent alkanes shows that alcohols have much higher boiling points. With alkanes, induced dipole-dipole interactions need to be overcome, whereas with alcohols there is hydrogen bonding that occurs due to the presence of OH groups, and this produces stronger forces of attraction, and so more energy is required to overcome them. Remember, when drawing hydrogen bonding, you must include a dipole on the OH, and then draw a dotted line to represent the hydrogen bond from the lone pair of electrons on the oxygen atom to the hydrogen containing the delta positive on another molecule. Do not forget to label the hydrogen bond. Alcohols are classified as being primary, secondary or tertiary. Primary alcohols have the OH on the end of a carbon chain, for example pentan-1-ol or 2-methyl-butan-1-ol. Secondary alcohols have the OH within the chain, so the carbon atom that has the OH is also bonded to two other carbon atoms, for example propan-2-ol. With tertiary alcohols, the carbon atom that is bonded to the OH group is bonded to three other carbon atoms. Primary alcohols may be oxidized to aldehydes. In doing this, it is necessary to set the apparatus up so that the aldehyde is distilled off as soon as it is formed to prevent further oxidation. We show the oxidation in an equation as follows. The potassium dichromate is used as the oxidizing agent, which will start off orange in colour but will change to green as the reaction proceeds. The H2SO4 is a catalyst. We can oxidize the primary alcohol completely to form the carboxylic acid if we have an excess of potassium dichromate and we do not distill but instead reflux the mixture. Refluxing is the continual evaporation and condensing of a reaction mixture which prevents loss of solvent. Secondary alcohols are oxidized by refluxing the reaction mixture to produce ketones. They are not oxidized further as the carbon-to-carbon bond is resistant to oxidation. This is the reason why tertiary alcohols are not oxidized under these conditions. To summarize, primary alcohols are oxidized first to aldehydes, and if you want the aldehyde, you need to distill immediately. If you reflux the mixture with an excess of potassium dichromate, the aldehyde undergoes oxidation to a carboxylic acid. Secondary alcohols are oxidized to ketones. Tertiary alcohols are not oxidized as the carbon-to-carbon bond is resistant to oxidation.
Alcohols can be dehydrated, that is, water removed, when they are refluxed with concentrated H2SO4. When a small molecule like water has been removed from a molecule, it is called an elimination reaction.
Alcohols react with hydrogen halides in the presence of a concentrated acid like concentrated sulfuric acid to produce haloalkanes. The hydrogen halide is usually formed in situ by reacting together the sodium halide with the acid catalyst. A substitution reaction then takes place where the OH group of the alcohol is substituted for a halogen.
Alcohols undergo complete combustion in a plentiful supply of oxygen. Balancing this type of reaction is similar to balancing combustion of alkane reactions. In this case we have 4 carbons in butanol, so we will form 4 molecules of carbon dioxide. We have 10 atoms of hydrogen, and this will make 5 molecules of water. Now we balance the oxygens. We have 8 oxygens from the carbon dioxide and 5 from the water, to make a total of 13. However, we have 1 oxygen from the alcohol, so that means we need 12 oxygens on the left-hand side, and so 6 molecules of O2.